So today I'm going to review this signal generator from Junctek. It's the JDS8080. Stick around, find out how good it is. Nice packaging, little quick start guide thing, got a USB cable, got a BNC cable, short one, it's like about 50 centimeters. Got one with clip leads on. We got another one with clip leads on. Have the mains cable with the correct plug. And here's the actual unit. So this unit's been given to me at no cost by Junctek for the purpose of review. So just a full disclaimer there, I haven't paid for this. So let's have a look at it. So controls we've got a mem inbox, shift, power button, soft keys over here, Wave system sweep VCO measurement outputs, channel 1, channel 2, which will be enabling outputs on and off, and you've got some controls here for doing various functions, and that clicks. We have a tilting bail, that works alright. Bit wobbly that way, could be my disc, that way seems fine. Okay, and on the rear panel, got a AC input here, universal power, 85 to 264 volt. This sticker is bubbling up again. I showed this in the mailbag and actually just like pushed it down. I'm guessing it's not been aligned correctly because this side's got a gap, this side's pushed right up. I think they just haven't quite got the sticker aligned properly. Anyway, minor detail. Got a hard power switch on the back for the AC mains. Got a DC 5V input, so you can power it for AC or DC. I think I probably prefer to power it off DC, to be honest, if possible. I think if I was actually installing this on my bench, I'd probably run a 5V power supply to various bits of equipment and help reduce the noise, because AC power supplies, or the switching supplies, all generate noise to some degree, and as you get more and more equipment, the noise gets worse and worse and worse. And I've been trying to deal with that recently in my bench. Things are getting ridiculous, so I've been trying to minimise it. So that's in my head right now about EMI and RFI. Probably mostly RFI actually. If I run it off 5 volts, so it probably would solve that problem. And we've got USB power over here as well. I don't think you'd be able to power it off USB. You might be able to. We could actually check for that maybe. And sync in and out here, and we've got a GPIO kind of connection here. If you've got 2 or 3 of these, you can link them together to the sync apparently. That way, instead of just having 2 channels like this has got, if you've got 2 of these, you could end up with 4 channels. That could be handy. So you've got a little quick start guide as well. So we've got this. So it's got an iOS app, which I've already downloaded for my phone actually. I've already got that. It boots up at least. I haven't actually tried obviously using it because I haven't powered this up yet at all. But I've got the app ready to go. There's an Android app as well, and there's also an electronic manual which I've also downloaded and installed on my computer. So that's ready to go. There is software for running this on a PC as well. I don't have a PC, I use a Mac, so I'm not going to be using that software. I imagine it works fine. So if you don't have any experience at all with signal generators, this will get you started, as it says on the front cover. Different modulation types, because it can do modulated waveforms, because this particular unit does go up to 80 MHz on a sine wave. The electronic manual has the specifications in it as well. This doesn't have them, which I find a bit interesting. And there's the software stuff. So if you actually do the PDF of this, I'll link it down below in the description to get to the software and the PDF links. It's got links in here, like it's got it here. There's the address for the software, just there for example. And in the PDF you can actually click on that and go straight to it and download it. So it makes it a lot easier. So I'll chuck links down below for those. And there's the phone app options there, which means you can completely control this thing off an app on your phone, which can have its good points. Like if this is just out of reach, like in my case, I'd probably put this on the back of the bench or something like that and just have the cables coming down. I could have a phone or a tablet here right next to me and I could control it with that, and that could be quite handy. I think it requires Android version 5 or newer and iOS 9 and newer. Shouldn't be a problem these days, to be honest. So that's a quick start guide. Now the first test, which I'm already prepared for, is to see if this will power off the USB port. So I don't know if it will or not. Let's plug it into power. I won't turn it on yet, I'll plug it in first. just want to see if this will actually power up. Now obviously this won't use this switch because that's only for the AC. So let's turn the power on there. Drawing 10 milliamps, so there's some power going somewhere. Nope, that answers that. It does not work off USB. Well, the power isn't one from a USB supply, which is a shame. That's actually a good opportunity. But then also, I suppose if you think about it, when you're running things from a USB power supply, you are then tying your instrument to your computer. So these posts are be referenced to your computer's power supply. That may not be a good thing. So running off USB, not necessarily the best thing. It's something you could get caught out by very easily if you're not really aware of it or not thinking about it. So what I think it will likely actually have there on that USB, because it was drawing a bit of power, it's probably an opto-isolated or some kind of isolation between the USB and the unit itself. So there may be a ground connection which is shared, but the actual power supply probably isn't. It's probably only used for running opto-isolation or something to isolate the actual electronics in this from the computer, which is what's commonly done in order to ensure there's isolation between the devices. Not everything does that, some things don't do it. If it has it, that's great. Maybe we'll find out when I open it up. So what I think I'll check for next is the grounding of this unit and determine whether there's a grounded to the mains earth or whatever is going on there. So I've got the Fluke 289 here ready to go. Alright, so they are indeed connected together, so they're not isolated from each other. I'll stick that on there, and we'll stick it on the back ones. They're connected together. The ground post on the back there is connected to it, and the ground post here is not connected to it. So the AC grounding is isolated from all the other shields, I suppose. So this earth is not this earth. So if you did want to use this and have best protection without any potential floating voltages, I recommend you would actually earth this properly with this pin, because that's what this earth point here is for. You tie that to a negative point. Let me actually check something else. I expect all these negatives are going to be tied together, so check the negative on the DC jack. Yes it is, DC, and on the USB, yep, USB negative is tied as well. So all the negatives are tied together, just not onto the earth. It's got its pros and cons for that. The pros are that your BNC jacks at the front aren't earthed, which can be beneficial sometimes. Sometimes you actually don't want them to be earthed, you do want them to be isolated. But usually you do want them to be earthed. So I suppose the fact they've brought out the grounding point on the back here to allow you to choose whether you earth it or not, that's not too bad. I mean, you could actually just have a wire coming from this. Literally, you could run a wire from this, and in my case, like I've got a power supply here, which has got earth points on it. I could just run the wire, plug it into one of those earth points, and then this would be earth referenced. So in a way it's good that they're giving you the option, but it's one of these things you need to be aware of, because if these are not earthed, because you're using a switch mode power supply, you can actually get ghost voltages being generated on these compared to your earth reference. So you can actually measure a voltage between these and earth, because it will just float around and build up capacitance and that sort of stuff, and it can be problematic. You may actually get even a shock of it sometimes too. You build on a voltage, get a shock off it, or maybe damage some sensitive equipment most likely. Yeah, it's more likely to be a case of wanting to ground these really. So I've got it hooked up here, ready to go. So this will tell me the power this is using in standby and when running. So let's turn it on. We're currently drawing 1 watt, so obviously the switch is powered on at the moment at the back. I'll turn the switch off, that's gone to 0 watts. So in standby it's drawing 1 watt continuously. Not a lot, is it? But it's still wasted power. 1 watt's not too bad. So what I actually want to check for, so because my power supply and stuff are earth referenced, I'm going to go to volts, nothing there, but I am seeing an AC voltage there. Alright, so right there, even with the unit turned off, I'm getting 25 volts onto this front BNCs. So that is the ghost voltage which is present. It's negligible current, right? The current there will be really, really small. So I'll just change my meter configuration to be microamps AC. Let's see if we can actually short this out and see how much current there is. There you go, 117 microamps to short that out to a ground point. So that's how much current will flow, 117 microamps. Not about much. So what I'll do now is turn it on, and we'll see if that changes anything. Alright, so nice little boot up screen. That boots up really quickly. Prompts for the language first, English or Chinese. 2 options. Well, I want to go English. Oh, that beep was loud. I don't mind beeps normally, but that's pretty loud. Okay, now it's running. Let's check this again, see if anything's changed. It's increased very slightly to 122 microamps. And if I look at the voltage, .23 volts hasn't changed. It's gone down slightly for anything. Just something to be aware of. So when it's running in this particular condition, it's sitting at 5.8 watts. That's not using much power at all when it's actually being used. We'll turn these channels off. See everything off. It goes down to 5.3 watts. We need to hook up to this thing and actually do some testing on it. So notes about the frequency on these. There's 2 models of this. There's the JDS8060 and the JDS8080, which is 60 megahertz and 80 megahertz respectively. So that means that the sine wave will do that frequency. Like square wave is up to 15 megahertz, for example, across both models. It's only for the sine wave we get the higher frequency, which is unsurprising. That's quite common. This output's 50 ohms, 50 ohm termination here. Apparently it's got like 50 ohms output plus or minus 10%, so it could be 55 ohms or 45 ohms. We could actually test that actually. Let's measure across this output terminal. Exactly 50 ohms. That's pretty good. Happy with that. The other one I expect is the same. Now what they may mean by the plus or minus 10% though is reactance. See, this one's slightly higher. This is 50.74, so this one's slightly high. So channel 2, this one's actually slightly better than channel 1. Obviously don't do that with the power output turned on because you may cause some damage or something. Because don't forget this is injecting voltage through to determine what the actual resistance is. Also, if it's your first time here, don't forget to click like if you like the video and subscribe and catch more of my videos. So here's a screen protector. We've got to peel that off. Right, you ready for the screen peel? That's better. So here's a nice close-up view of the screen. So we've got frequency, amplitude, offset, duty, phase. Basically the same thing, just kind of reversed. Phase is a standalone by itself between the two because there's phases across both channels. So you can set the frequency of each channel individually and you can adjust the phase in between the two channels. So right now they're both in phase with each other. If I made it say 180 degrees out of phase, then you'd be the highest peak on this one would line up with the lowest peak on this one if they're at the same frequency. On this side we've got frequency, amplitude, offset, duty and phase adjustments over here, so obviously you can choose which channel it is, I guess. We can do that channel, or if we tap on that one it'll go to that channel. Right, so you can choose them off those buttons over here. So that's all fine. Amplitude 5 volts. Now this can do up to 25 volts peak to peak, reducing down to about 3.6 volts peak to peak I think it was at the highest frequency. So I think it like has steps in the actual amplitude levels depending on what frequency it's generating. So at the lowest frequencies you can do 25 volts peak to peak, highest frequency is about 3.6 I think it said it could do. Offset, so you can do DC offset on these as well. I think it can do minus 10 volts and plus 12 volt DC offset I think it was. Duty cycles, you know, usual stuff, and phase adjustment here, so basic stuff. So waveforms, we can choose sine wave, square wave, and it gives you a representation on the screen about what it's actually going to do as well. Back to waveform again, pulse, triangle wave, and that's given options. The other way you can do this as well is you can also use the dial over here, and it will go through the different ones. And it's also got optional ones, you can put all your own ones in there too. You obviously program those in through software. Anyway, we're going to stick with sine wave for the time being. Modulation, so we can modulate the sine wave or the waveform we've got. So if you push that, we can choose modulation frequency. In this case, set at 500 Hz. I'm going to change the frequency to be 1 kHz because that's a modulation frequency I like to use. Depth 80%, that's fine. Internal modulation, because you can do external modulation on this jack here, you can supply your own. If you want maybe a more complex modulation, just like a standard oscillating waveform, maybe you've got some other modulation source you want to put in there. Maybe it's audio modulation, you want to do some testing or something like that. Sine wave shape AM modulation. So do type AM, we can do FM, phase modulation, ASK, FSK, so it's amplitude shift keying, frequency shift keying, phase shift keying, PWM, burst, that's it, burst. Okay, so get it back to AM. Modulation depth in this case is 80%, like I say. If you want FM, based on frequency deviation instead of amplitude, so in this case it's 2 kHz deviation. So let's turn modulation back off again, done modulation right now. System, so looking here, what we've got: clear memory, sound, let's go up and down, shall we? Sound on, yeah, I'll leave it on. Brightness 100%, sure. English language, put in waveform 39, arbitrary 15, load waveform auto. System information, okay. There's a system information. Hardware version 2, firmware version 2.08, FPGA 2.88. Okay, what else is there? Page down. Waveform sync, frequency sync, amplitude sync. This is for the sync sockets on the back there, which I pointed out earlier. Duty sync, external sync, frequency fine tuning, which means if this is off frequency, you can tweak it a little bit. If this is off frequency, say trying to do say 80 megahertz and you're getting 80.001 or something instead, you can use this to tune the frequency oscillator that's inside this thing to compensate for that, so you can get the accurate output frequency. Nice little feature. Now, I did actually review a Junctek before. It was a 9080, PSG 9080 I think it was, and that had exactly the same setup in here. Exactly the same. So let's just leave those alone. Page down again, goes to this final page. Auto power on is off. Amplitude fine tuning of channel 1, channel 2. So if the amplitudes are out of spec, like if you're, it says 1 volt, we're doing 1.01 or something, again you better tune these on here, and you can download the user manual from that too. And back to the beginning. So you've got sweep function, which means you be able to sweep between 2 set frequencies, put in both channels. Yep, both channels can do it. You can set the start frequency, how long you want to sweep for, so how long it will take to complete that sweep, and the kind of sweep you want. Sweep direction. Round and decrementing. Round, decrementing. Incrementing, decrementing, increasing, decrementing, increasing. Okay, and then we've got sweep mode line. So linear, not line, linear, and logarithmic. They should have an A on the end of that. So it's a straight, continuous straight line between 2 frequencies basically, and logarithmic. You can turn it on there and then you can see what it's doing. So this will increase slowly, or start off slowly and get faster and faster and faster because it's logarithmic. See how that works? Okay. VCO, so voltage controlled oscillator. So I believe you can put that input onto this jack here, and depending on the voltage you put in, so we've got voltage calibration points here. I think it can be up to 20 volts. I think it said it could be. It will adjust the upper frequency depending on what the voltage is coming in, which is what a VCO is. It's a voltage controlled oscillator. So input voltage, you output frequency, and again you got options here for logarithmic or line, which should be linear. Anyway, and measurement, you can measure frequencies. Yep, so it's got a frequency counter built in, or a pulse counter basically. So frequency counter or pulse counter. Low frequency, which is below 2 kHz, which gives you high resolution. High frequency, above 2 kHz, which I think goes up to 100 megahertz maximum. And outputs turns both outputs on and off at the same time. Okay, get back out of there. So I thought I'll just look at, you can see on the camera here the angle of the display. You can see this angle here is fading out. As I bring it around you see more and more and more. And bring it around this way, same thing, it fades out. Now that actually is more on camera than in real life. I can see that display pretty well most of the way. It does have some off angle artifacts there where it does tend to fade out, but it's not as severe as it looks on camera. I think that's partly to do with the filtering on the camera. The camera's got like a polarizing filter on it, so it's probably to do with that. Well, let's actually turn the output on this thing. This is set to currently 10 kHz, so let's turn the output on and we'll see what we get. Okay, my horizontal scale is incorrect. Just adjust my time base. Okay, so I've adjusted the time base now, so you can see the waveform on the display there. So this is a 10 kHz waveform, and you can see on the top of the scope here, you can probably just see it. It's just below 10 kHz, it's not exactly right. So it's slightly off frequency, I think. I won't actually know until I put it on a frequency counter, which I should actually turn on and get it warmed up. We'll actually check the frequency on a frequency counter. Let's turn on modulation. Have a quick look at that. It's doing AM modulation right now. 1 kHz, 80% modulation. So if we change the time base, you should be able to see the envelope waveform. You can see it there. So there you go, there's an envelope waveform. Because the frequencies are quite low, it's only doing 10 kHz with a 1 kHz modulation, which it should be 10 modulation pulses per cycle of the actual carrier frequencies. That's the carrier, and these are the modulation inside them. So between that point there and that point there should be 10. So let's change the actual carrier frequency. Let's do 10 MHz instead. So there's our 10 MHz waveform there, and we're actually getting a higher frequency here, 10.00994. So yes, we do have a discrepancy there. This scope is actually very close to correct. Right, turn the modulation back on. We've got some aliasing going on here, which is not surprising. Let's change the change the time base. We'll bring this up to get a nice waveform envelope. There we go. So AM waveform envelope. Bring this up here some more. There's an AM modulated carrier, 80% modulated. So if I go to 100%, it should basically have a crossing over there. So that's 100% right now. That's not looking too bad. See, that's a nice. Basically, you should get two sine waves one on top of the other, and we basically are. That's 100% modulation. That looks right. 110 should be too much. Yep. And it goes apparently up to 200%, which means you actually get two sine waves. Overmodulate so badly it crosses over itself. Basically, with AM though, you don't want to be doing anything like that. That's not good. Generally, that's what you want at most. Is that. So yeah, that's all fine. That works nicely. So now set it up to sweep. I've got it set at 400 kHz to 500 kHz. So that's the sweep it's doing right now, which would be great for doing like a bit of radio work, testing an IF system or something like that. You want to make sure the IF is tuned. You can actually see the response across that sweep. Now I've got it sweeping in 1 second. It takes 1 second to sweep. So I can actually slow this down so you can see a bit better, I suppose. If you want to look at levels, you can probably do that. If I actually reduce my time base a bit more. But yeah, that works fine. So let's actually go back to 1 second, and we'll go down to this one, which is increasing. This one's decreasing, so it goes the other way. Or it calls it decrement. Increasing and decrement, that's the switching. Yeah, and round means it'll probably go up and down, up and down, up and down. Now what I'm going to do is change back to 2 seconds or something. Maybe go 5 seconds so you can see this one. Yeah, that one's bouncing up and down now. There you go. So it goes both ways. Up and down, up and down. So that might be more useful actually in most situations to see what's going on. Because otherwise you get jarred when it goes back to that starting point. You get a bit of a jarring change, which is a bit nicer to look at. So that works fine. So that function there, in certain situations you've got sweep F, which is sweep frequency. I push the function button out, it offers a sweep A, which would be sweep amplitude, which means you can sweep across different amplitudes at a set frequency. Let's see what we can actually go up to on voltage on this one. So this is at 10 MHz, don't forget. Yes, it is 10 MHz, and I just want to see what the maximum voltage is here. 20 volts peak to peak is most we can do there. Okay. This actually changed my vertical resolution here, 5 volts per division, and let's wind this up. There you go, 20 volts peak to peak. The triggering slightly off there, but yeah, that's working fine. Oh, I just noticed a mistake I've made. My frequency isn't set to exactly 10 megahertz. It is set 10.01 is what it was set to. Right, so let's do system again. We'll go down and we'll find that frequency tuning again. And we'll try this again. Now you can see I'm actually below 10 megahertz just here, so I need to tune that back up. So I'm going to put it back at 50, where yeah, 50% we started out as from the factory. How close is that? That's down by about 70. So I'll bring this up some more. There we go. Okay, about there. So that is 62. So changing the tuning to 62 is about right. So the eagle-eyed of you may have noticed that my voltage here doesn't match what I've been outputting from this device. Now I do actually have a 50 ohm terminator on here, right? 50 ohm load is right there, okay? So that's what I've been using as this. Now my scope is currently set to 1 mega ohm input impedance. If I change 50 ohm, it's going to halve it again. So I can either do two things. I'm going to take off the one I've got on the outside, which is rated at 5 watts, or switch to this scope's inbuilt 50 ohm termination, which will drop the level down. Oh, just turned off as I was going back. Click it. Just here. Right, it's got built in. Not all scopes have got built in 50 ohm termination. This one does. But what I'm going to do, instead of risking the front end of the scope, I'm going to change the probe setting. So now I've changed it to ×2. That will effectively compensate for that loading, and we're now getting 5 volts here, which is what this thing is currently generating as 5 volts peak to peak. Right, so reconfigure my scope slightly here. I'm just going to go straight in now. So I've got this set for 1 volt output at 10 megahertz right now. You see the waveform here at exactly 10 megahertz now. So what I need to watch out for is this dipping down to 0.707. That's a 3 dB point. So I should be able to increase the frequency and have it stay above that level, right? So you can hopefully just see it there. It might not be the best focusing and stuff. That's probably about as good as I'm going to get for you. Right, let's do that. So one frequency up, so 10 megahertz. 30. It's actually going up there. 900 there, there's a 70, and it's doing 890 millivolts or so there at 80 megahertz. So yeah, it's definitely meeting the level. Anyway, the level is looking pretty good. It does have some unevenness in there, but that's because I probably took the terminator off there. So let me just put the terminator back on. That gives us the levels again. So we'll go back down. So 10 megahertz, we're getting 1 volt there. Let's increase the input level here. See a bit better. So there's 1 volt there at 10 megahertz. Still got a slight peak there. Actually went up at 80 then, so down at 80. So you just got to show how the termination matters. So the cable and the termination does matter, but yeah, as far as level goes, that's not a restriction. That manages just fine. Let's just try the DC offset here. I do have AC coupling on this, so it shouldn't move. Let's do 1 volt DC offset. Yep, nothing there. So let's change this to DC coupling. There we go. Now you've got a 1 volt offset. Bring it down by 100 millivolts at a time. Yep, that's working fine. And I guess we can go negative as well. Yes, we can. And that's also working fine. Yep, no worries at all. So let's play around the sweep function and see if I can get it to sweep each channel independently. And I can't seem to get to do that. It displays that channel, but it doesn't actually sweep independently, I don't think. At least not with independent controls. If I sweep frequency instead, I'll get a square. So it's just not really, yeah, it's not really doing what I want. Yeah, I can't actually get the sweep independently. It's basically one channel or the other. But by changing frequencies, this is in XY mode on the scope, you can see different patterns and stuff. Just interesting. Or anything else? Is it residue patterns or something like they're called? I can't remember what they're called now, they've got a name. Anyway. Depending on the frequency reaction between both channels. Anyway. Yeah, that's that. So I've got it hooked up to the frequency counter. I'm generating 1 megahertz right now, and that's the frequency we're getting out. And if I go into system and we go down to that adjustment again, that's the alternative. That's a step of 1. So that's a 62, which is what I had in my oscilloscope looking correct, and that's 61. So yeah. Yeah, it's it ain't perfect. So decimal place is kilohertz, so below decimal place is hertz, so that's 370 millihertz high. Well, I suppose the next thing we should do is pull it apart and have a look inside it. Let's get a screwdriver. I believe the top will come off. Probably. Looks that way. Somehow. There we go. It just sort of clips in there. Okay, there we go. And that's what's inside. So the earth connection comes in and goes to this board. So the board does have some kind of protection on it. Wouldn't say it's a lot though. And yeah, okay. So I've got a cap here, it's probably hundreds of volts. Set a 400 volt cap, yeah, there we go. So you've got some switching stuff, you've got a bridge rectifier here, that will inductor there, which is probably a common mode choke. You've got some protection here, the MOV, the inline fuse, that little brown thing just down there, that's a fuse. Also the main transformer for the actual switching. And a couple of caps on there, which will be polymer caps of some kind. And it's got a voltage output, which is probably, well, my guess would be a 5 volt supply. Now in this section, we've got earthing on this board, which is going up to this tab up here, which we knew about. So I actually think all this really needs to make this better is to run an earth wire from this point here to this point here. And that would earth everything. I really think that would solve the problem with the floating terminals. It's got a programming header over here. Obviously the output devices are underneath these heat sinks here. Some kind of processor underneath that block there. All these traces go into it, so that's a pretty busy part there. A whole bunch of discrete parts which have got no numbers on them, have all been lasered off. Got some relays there. Bluetooth module, that's right, this has got Bluetooth, I haven't shown you that yet. There's a Bluetooth module there, so this is a standard plug-in module. You can buy these modules. So there it is there. I can't unplug it because it's got this post in the way, but it's a standard plug-in module. Off the shelf part, lovely. So yeah, you can actually use Bluetooth control. I should actually fire that up and show you that. Prove it works on iOS. Some kind of processor on the back of that front panel there, but as you can see, it's also been lasered off. No numbers on it. I'm sure someone can reverse engineer it if they tried. Also, just behind this Bluetooth module here, that round thing there, that's the beeper. So if you want to make it quieter, you get a sticker put over the end of that, and it'll make it quieter because there's a hole in the end, which is where the sound comes out. So I thought I'd just have a little look at this a bit more closely. And so you've got the earth tab at the back here. Now the earth tab comes onto the board, which has got a nice exposed pad there, nice metal exposed pad. But check this out. That isn't even tight. That is not a good earth connection. Look at that. That is not acceptable, people. So you got earthing for safety, and it doesn't actually earth properly because it's not been done up. Incredible. So I just modified this. I put a earth wire from this terminal here round over to here where the one which wasn't screwed in properly is, and that's all tightened down securely now. Yeah. The thing is though, these are plastic screws going to plastic. It's not actually nicely bolted, but that's what's there. It's not ideal. Secure enough, but not great. Right, let's look for the app here. So I've got the app loaded up already. Just went to the App Store, looked for the JDS8080, and it came up as an app. So there's only got like 4 apps, I think, something like that. So it's not exactly hard to find. You can change stuff on here. It's not exactly hard at all. So you have to give this permission to use Bluetooth. And one thing I did notice that this particular screen, you'll see it's in Chinese here and here, and all the others all fully English. So this one screen, the sweep screen, hasn't been translated fully. There's also some over here as well, and it does scroll up and down, and there's a bit more there. So it's in Chinese in here, which I can't read. So and you've got a settings screen as well. So if I wanted to change, what I'm doing on here is changing this. So if I wanted to change something on here, I don't know what I'm changing something. Sine waves, apparently. Some Chinese here as well, in there. So it looks like it's not fully done. Not quite sure about this. Amplitude. Change the digits in amplitude. Wind up and down. That's changing it down here on channel 2. Channel 1. Here we go, channel 1 controls, but so I don't know what this Chinese thing here is saying. Is that saying modulation then? Must be modulation. And then again we can change this up and down, and it is changing on here. I'll put on and off, we can do it from here too. So that's that button just there, turn it on and off. Same for channel 2, so that all works. Measure function, yeah, so you can do all that stuff. System sync, yeah, so it does all that stuff, and so you can control it just fine from the phone. Not a problem at all. Could be handy for someone. So thanks a lot, Junctek, for sending this to me at no cost for purpose of review. If you liked it, give us a thumbs up, and you can check out the videos down below. I've got other review videos and repairs, stuff like that I do. Catch you later. Bye.